Hi, I'm Shamar Pearson. Today we will interpret the importance of space exploration using logical intelligence. Have you ever come up with a new way to use something that was designed for a different purpose? Using scientific knowledge to develop new products is called technology. New discoveries are constantly incorporated into products. NASA often creates advanced technology to meet the special demands of space travel. Many spin-offs of technology are from the space program and can be found in homes, offices, schools, and hospitals. Engineering design process is observable in the creation of most designs. The process begins with identifying the problem for which the engineer is aiming to design a solution. The problem must be fully defined, which requires the engineer to fully identify all criteria and constraints involved in the problem. Engineers also need to complete research to gain a better understanding of the problem and its potential solutions. After an engineer creates a design he or she wants to pursue, he or she must construct a model of the design. The model must be evaluated through trials and tests to reveal if the design is a viable solution to the problem. Engineers refine the design or prototype in response to data on one model before creating another, saving time, effort, and resources. After the design is complete, engineers should share the design appropriately based on the situation surrounding the design's creation. One of the first uses of space technology was building tiny electronic circuits. These parts were developed for spacecrafts. This technology made microcomputing and handheld calculators possible.
Here is a diagram of the engineering design process. I want you to look at the highlighted word improve and iterate on your design. This step is the iterative design process, which is the idea that improvements and adjustments can be made into a design throughout the entire design process. This allows for implementations of any improvements or changes and steps that have already been completed at least once, allowing more thorough and continuous evaluation of the design. And here we have some of the factors in space, like space radiation and isolation, confinement, distance from Earth, hostile enclosed environments, and altered gravity fields. While constraints are factors and conditions that restrict the ways that the solution can satisfy the criteria or things that the solution cannot do, criteria are important to consider because the solution satisfaction of the criteria largely determine whether the solution is successful at solving the defined problem. Everything on a spacecraft, for example, must be small and lightweight as possible because the heavier a spacecraft is, the more difficult it is to launch. The design techniques developed to meet this need have improved devices on Earth. And here on this graph, it brings up the effect of how the individual factors can be affected from extreme heat and cold in conditions in space. Humans need a safe environment in a spacecraft and a space station. Materials and parts on a spacecraft have to endure harsh conditions such as extreme heat and cold. The making of Echo 1 satellite led to the development of lightweight materials that reflect light and heat, material made for special blankets and food packaging. Technology from developing spacesuits have been used for making warm clothes. NASA has developed systems for purifying water, food, and air. These systems now help protect people on Earth as well as in space. We are able to have new information about science being shared by people in all countries. Not all discoveries are from space exploration. Often discoveries are made by people pursuing a hobby, but space exploration and blended learning make us be a part of the space age.